first section of the Sydney-Newcastle Expressway, the first rural expressway in New South Wales, was officially opened by the Premier, Mr. Askin, in 1965. Before the motorist could enjoy facilities such as these, many people in various occupations combined their knowledge and skills to plan and execute works of great magnitude. This is the story of those people and the job done by them. Sydney, now one of the world's largest cities, is the centre of commerce in the state of New South Wales, and there has always been a need for a connection between the state capital and Newcastle, the state's second city and big industrial centre, 100 miles to the north. Early access between the two cities was by sea. Road connection followed slowly with the old Putty Road in 1820. Wollombi to Singleton in 1826, Wiseman's Ferry to Maitland in 1829, Gosford to Maitland in 1841, and the St Albans route in 1844, all passing around the upper reaches of the Hawkesbury and its tributaries. In 1844, George Peat established a more direct route with a passenger ferry over the Hawkesbury at Mooney. Parts of this road with its impressive stonework can still be seen. In 1889, via Wiseman's Ferry to Gosford and along the coast to Newcastle. Later, the Wiseman's Ferry Spencer deviation was opened. The ferry and road served as the principal access between Sydney and Newcastle for many years. A shorter route via the Pacific Highway used a vehicular ferry over the Hawkesbury. The highway, with its easy grades and best possible pavement of the day, was hailed as a great engineering achievement and was a boon to motorists in the 1930s. The Peats Ferry Bridge replaced the ferry in 1945. With post-war development and the increased use of motor vehicles, the capacity of this road was soon outstripped. In an effort to keep pace with traffic growth, climbing lanes were added on steep grades. Visibility was improved to assist overtaking. A new high-standard route of 20 miles in length provided further relief. This road bypassed Gosford. It became apparent that even with improvements, the existing routes could not be expected to keep pace with the anticipated traffic growth in the immediate future. An expressway was planned to link the two cities and provide a fast road to Gosford and the rapidly developing Central Coast. Initial work was between the Hawkesbury River and Calga. Surveys were carried out preparatory to design and construction. Distances were determined by tellurometer, an instrument which measures length using reflecting radio waves. Targets were placed on survey points for control of aerial photography. Ground detail was recorded by flying over and photographing the targeted area, which was extremely rugged. The aerial photographs were scanned in a stereo plotter made available by the Lands Department. And ground details translated into contour plans. In the Department of Main Roads Drawing Office, the road location was fixed, a task made extremely difficult by the need to accommodate an expressway and a highway on the narrow, rugged, steep neck of land between the Hawkesbury and Mooney Creek. Steel splines were manipulated on the contour plans. Aerial photographs examined to achieve the best alignment. Particular details were examined by constructing models from corrugated cardboard. The Abbott apparatus, comprising cardboard cross-sections supported on retort stands, also assisted in the design. Detailed drawings were prepared. The final plans and specifications were then handed over to the resident engineer of the construction organisation. The expressway north of the Hawkesbury was built in 3 sections from Mooney Point to Calgary and connecting with the new route to Newcastle. A contract was let in 1963 for the construction of the first section of just over 4 miles between Mooney Point and Mount White. This section included an interchange at Mooney Point. It was here at Mooney Point that work commenced. Engineers inspect the site at the start of construction. The first operation was to clear the area of timber, which was felled mainly by chainsaw. The width of clearing was kept to a minimum and debris burned within the cleared area. Before earthworks could proceed at full pace on Section 1 of the expressway, 4 lengths of the existing highway had to be relocated, requiring the construction of 2 miles of road through very rugged terrain, which involved the working of heavy earth-moving plant in confined areas and on steep slopes. Material was moved from cuttings to fills by bulldozers and motorized scrapers. When earth-moving plant crossed the existing highway, it was essential in the interests of safety to control the flow of traffic. Rock ledges were removed by drilling and blasting. Tip trucks transferred material from cuts via the existing highway to the fills. After spreading, the material was thoroughly compacted by rolling. Retaining walls constructed with local sandstone block or concrete crib units were required at some locations to support fills. The relocated lengths of highway were paved with asphalt before being opened to traffic. Bridges were constructed concurrently with the relocation of the highway. At Mooney Point, a pre-stressed concrete structure was being built. This shows the completed Mooney Interchange Bridge. During construction, steel reinforcement cages for footings and columns were placed in trenches, previously excavated to solid rock. Concrete was batched at a plant near the expressway. Mixing was carried out in transit mixers during transport to each bridge site. concrete was discharged from the transit mixers into hoppers for placing into formwork. Meanwhile, at Joel's Lookout, 2 miles north of the Hawkesbury River, twin bridges, each of 7 spans, were constructed. The narrow ridge between Hawkesbury River and Mooney Creek was not wide enough to support an expressway fill. Bridging was the economical solution. Transverse pipe culverts were constructed prior to commencement of full-scale earthworks on the expressway. Before excavating cuttings, the area was cleared of vegetation. The topsoil was removed and the rock was drilled at a 1/4-to-1 slope for pre-splitting with explosives to form batters. Softer rock was loosened by ripping and the cutting was excavated to median level. The median batters were drilled for pre-splitting. Was drilled for loosening with explosives. And was removed from both sides simultaneously. The cutting was excavated to subgrade level, but the median was retained as a rock island. Before commencement of fills, the area was cleared of vegetation. Topsoil was removed and the surface benched at 1:10 slope to support the toe of the fill. Material was placed in layers 8 inches thick. The natural surface stepped or roughened in advance of each layer. A rock facing was provided 4 feet wide in advance of each layer as the fill progressed, and the fill slope was generally 1.5 to 1. A sub-base layer, 12 inches thick, was placed above subgrade level using selected sandstone. On the first section of the work, 2 million cubic yards of rock had to be excavated and moved to fills. In the early stages, all rock was loosened by ripping. Later, it was supplemented by drilling and blasting. The series of delays introduced into each blast resulted in good fragmentation. A mechanical shovel of 2.5 cubic yards capacity was used to load broken rock into trucks for hauling to the fill. Mid-1964, 12 months after commencement, work was well advanced over the full length of Section 1. To give the motorist a longer length of expressway at an earlier date, it was then decided to accelerate the project by proceeding immediately with the construction of Section 2, 1.6 miles long at Mount White, which included the Mount White interchange. One length of the existing highway required relocation. Section 2 was constructed by the Department of Main Roads by direct control, and an engineering organization and depot were established at Mooney. Operations were planned in detail using the critical path method to determine the most efficient program for the work. A computer was used to assist with the analysis. bar charts were produced for use in job control and for recording progress on the work. Earthworks were carefully controlled using survey instruments and coloured profiles to define batter slopes. About 50% of the rock was loosened by ripping, using the heaviest tractors available up to 425 horsepower. These tractors were fitted with rear-mounted hydraulic rippers using a single tine. Material loosened by ripper was moved by motorized scrapers. These units were capable of carrying up to 30 cubic yards of material at 30 miles an hour. A typical team consisted of 5 scrapers with a tractor dozer push loading and 1 or 2 ripping tractors. Material was discharged from scrapers on the run and spread out in thin layers using bulldozers before being rolled. With this equipment, outputs of up to 10,000 cubic yards of earthwork per day were achieved. Rock which could not be economically ripped was loosened by drilling and blasting. Holes 2.5 inches in diameter were drilled using crawler track-mounted drills capable of penetrating at more than 1 foot per minute. Holes were generally 14 feet deep, but increased to 30 feet when rock strata was favorable. The explosive used was generally an ammonium nitrate fuel oil mixture, prepared in small batches near the site. The main charge was primed with gelignite, connected by instantaneous detonating fuse to electric millisecond delay detonators. To avoid misfires, detonator circuits were tested by measuring their electrical resistance. The shots were then fired. Rock which was loosened by blasting was generally too large for moving by scrapers, so it was loaded into rock buggies or trucks for hauling to fills. A mechanical shovel was used for loading rock, but generally front-end loaders of 2 to 4 cubic yards capacity were found more suitable. Compactors fitted with rock rakes were used to separate the larger rocks. These were moved to the outer edge to form a rock facing about 4 feet thick on the fill slopes. This process provided a scour-resistant surface. The finer material remaining in the body of the fill was spread by bulldozer and watered to bring it to optimum moisture content. At this stage of the operation, sheep's foot rollers compacted the material to its maximum density to prevent later settlement. The action of this type of roller is to compact each layer from the bottom upwards. Each layer of the fill was tested in situ for density. 2 methods were used. The sand replacement method involved the removal of a sample of material for drying and weighing. It was replaced by sand of known density to determine the volume. In the second method, a nuclear gauge determined density by counting gamma rays emitted from a radioactive source and backscattered by the fill material. Cut batters were cleaned down with crowbars and compressed air to dislodge any loose material which might later be a hazard to traffic. The top of the subbase was carefully checked for level and shape. The surface of the subbase layer was trimmed to preset levels by grader and the layers compacted by rolling. Grid rollers and steel vibrating rollers assisted with compaction. Earthwork was now well advanced throughout the whole length between Hawkesbury River and Mount White. On Section 2, earthworks and bridge construction proceeded concurrently. 1 mile south of Mount White, where the expressway crosses the existing highway, twin bridges were constructed. These twin bridges over the existing highway were built without interference to traffic. At Mount White Interchange, a 2-span reinforced concrete bridge was constructed to carry ramps across the expressway. This bridge was of concrete cast in situ on tubular steel falsework. To keep water clear of the expressway, concrete drainage structures were provided. Catch drains were constructed along the tops of cuttings to lead water into natural water courses, which drained into transverse culverts located under the road. Longitudinal culverts were placed to carry water falling on the road clear of the carriageway and shoulders. Curbing and guttering were provided through cuttings to collect water and lead it through gully pits into culverts. Subsoil drains were provided to intercept subsurface water. Median drains to collect water discharged in the median area. And precast concrete drainage units to carry water down embankment batters. Catch drains on steep grades were constructed in concrete to prevent scouring. Some median drains were also constructed in concrete. The concrete in both catch drains and median drains was coloured dark grey to blend into the natural surroundings. Excavations were made for longitudinal culverts. The culverts consisted of precast concrete pipes, bedded on sand and carefully aligned and graded. Concrete curbs and gutters through cuttings were initially constructed by pouring concrete into stationary forms. Later, the more economical and modern method of extruding concrete from a machine was used. Subsoil drains consisted of earthenware pipes laid with pervious joints in trenches. They were backfilled with specially graded filter material. At the works depot, concrete drainage units were precast. At the site, they were placed on fill batters to carry surface water clear of the road formation without causing scour. Meanwhile, work was proceeding on major structures. For Mooney Interchange Bridge, pre-stressed concrete girders were lifted into position on the headstocks. The ends of the girders were seated on neoprene pads set in cement mortar on top of the headstocks. Due to the widening of the expressway near the toll barriers, Mooney Interchange Bridge tapers in width from 205 feet to 221 feet. On Giles Bridge, headstocks were completed, ready to receive the girders which were manufactured some distance from the site. On South Mount White Overbridge, units 45 and 50 feet long were lifted into position whilst traffic continued to flow on the highway beneath. Work continued on Mount White Interchange Bridge, which features a box girder cast in situ type of construction. By mid-1965, from Hawkesbury River to Mount White, the expressway was taking shape. difficulty in establishing an expressway through this rugged terrain is here evident. At this stage, construction commenced on Section 3 between Mount White and Calga, a length of 3.5 miles. This section included two interchanges, one where the ultimate route will turn towards Gosford, and the second at Calga, where traffic continuing to Newcastle and the north separates from traffic proceeding direct to Gosford. 4 relocations of the existing highway, totaling 2 miles, were necessary on Section 3. On this section, 2 million cubic yards of rock was excavated and moved from cut to fill in a period of less than 12 months. Daily output increased as more advanced equipment became available and greater experience was obtained. At one time, these sandstone ridges were used by Aborigines for ceremonial purposes, and their rock engravings were frequently encountered during construction. The engravings were carefully recorded before blasting. In some cases, engravings were cut out and removed for preservation and public exhibition. Section 3 includes 3 bridges. 1, the Stub Bridge, crosses the ultimate expressway route where it turns towards Gosford. This is a post-tension concrete box girder structure. The single pier is V-shaped. Tubular steel falsework was erected to support the superstructure during concreting. The next bridge carried the existing highway over the expressway between Mount White and Calga. It is a post-tension concrete structure with a long central span across both carriageways. Piers and abutments were constructed of reinforced concrete cast in situ. Precast concrete sections were brought to the site, assembled on the ground, and post-tension to form girders. The third bridge was at Calga, where the expressway crosses the interchange ramps. It has 3 spans of steel girders. The pier columns consisted of reinforced concrete inside concrete pipes, which took the place of formwork. Pavement construction was now proceeding on sections 1 and 2. The sub-base of selected sandstone, 12 inches thick, was trimmed to the required crossfalls. The base course layer of crushed basalt was placed in 2 4-inch layers, giving an 8-inch thickness. After accurately trimming the base course, a bituminous surface dressing was applied, using 3/16 of an inch aggregate. The intermediate course of 3/4 of an inch asphaltic concrete was spread 2 1/4 inches thick. Asphalt curbs were provided along edges of the formation. The 10-foot wide shoulders, or breakdown lanes, were surfaced with a spray bituminous seal, using a 3/4 inch cover aggregate to give a coarse textured surface, contrasting in appearance and tire noise with the travelling lanes. They were surfaced with 3/8 of an inch asphaltic concrete, laid 3/4 of an inch thick. A mechanical spreader was used for laying the 8-inch thick base course, which was composed of graded crushed basalt from local quarries. After being watered, the base course was compacted by vibrating rollers. Surface levels were checked. Final surface trimming was carried out by grader with further compaction by pneumatic tired rollers. The largest, of 32 tons, provided for varying the tire pressures whilst in motion. A 10-foot straight edge was used to locate variations in the surface. A bituminous dressing was used to protect the surface until the next course could be applied. Prior to the application of the intermediate course asphalt, a bitumen emulsion tack coat was sprayed on the surface. Asphaltic concrete 2 3/4 inches thick was spread and tamped by a mechanical paver. The initial compaction was by a steel roller and secondary compaction by pneumatic tired roller. Tracks were laid to take an extrusion machine, which was used to place an asphaltic concrete curb on the outer edge of the intermediate course. A manually operated unit was also used for this work. In the meantime, holes were bored along the edges of all fills to provide for guardrail fencing posts. Application of the final pavement course was delayed until this and other work on the adjacent roadside was completed. The guardrails were secured. The roadside was landscaped to restore it as closely as possible to its original appearance. This work involved spreading of topsoil on fill batters and disturbed areas. Grass seed was planted. Fertilizer spread. And the area watered. The ground surface was sealed with bitumen emulsion to prevent scour and assist germination. The grass was quickly established. Grass sods protected earth drains, whilst the steeper slopes were planted with indigenous ground covers. Native trees and shrubs were planted in carefully selected locations to enhance the roadside appearance and reduce headlight glare. boundaries were fenced throughout to exclude people and stock, as this road was constructed for vehicles only. Using the extrusion process, concrete mountable curbing was installed at ramps where narrow medians were necessary. Outer edges of the travelling lanes were masked for protection before spraying bitumen on the shoulders. Aggregate was applied directly to the bitumen to give a cover of 1 stone thickness, and then rolled by pneumatic-tired multi-wheeled roller. After rolling, any excess stones were removed by compressed air and brooming. Travelling lanes were then surfaced with asphaltic concrete. A profileometer checked the surface to ensure that the final pavement was finished to within very fine tolerances. With the completion of the surface course pavement and the provision of signs, lights and other traffic facilities, the first 2 sections between Hawkesbury River and Mount White were brought to completion. These sections were opened to traffic in December 1965, using an interchange at Mount White to connect with the existing highway until the next section of expressway was completed. Earthworks then proceeded at an accelerated rate on Section 3. At Mount White, work was continuing on the stub bridge. After formwork for the girders had been erected, cable ducts were placed on the structure. Pre-stressing cables were prepared for insertion into the ducts. The ducts were then lowered into final position. Concrete was conveyed from transit mixer onto the structure by a monorail system. And placed into the girder formwork. After concreting, the high tensile steel cables were tensioned. The stub bridge was completed. Meanwhile, at the highway overpass bridge between Mount White and Calga, the girders had been assembled and stressed. They were then moved by jinker from the assembly area to beneath the bridge and lifted into their final position in the structure. Reinforcing steel was then placed in position for the deck. Transit mixers delivered the deck concrete. At the Calga interchange bridge, steel girders were in position. Concrete was placed to form the deck, and workmen applied the finishing touches. The third section of the expressway was then nearing completion. All signs were manufactured at the Department of Main Roads Central Workshop at Granville, near Sydney. Easily read signs with large lettering were needed for the high-speed traffic. Where signs were required above travelling lanes, steel trusses were constructed to support them. The signs were of different colours and reflectorized. At interchanges where overhead lighting was to be provided, signs were illuminated by fluorescent tubes. Reflectorized delineators were placed at the outer edges of the road formation, using a red colour to indicate the left side and white for the right side of the carriageway. A blue colour was used on interchange ramps. Toll collecting facilities were provided at Mooney Interchange using prefabricated cabin units. Cables for emergency telephones were laid in trenches along the edge of the formation. They were protected by a layer of concrete. Telephones were erected at 3/4-mile intervals and connected to the administrative centre, from where an emergency patrol wagon operates in the event of breakdown or accident. Lamp standards were erected at all interchanges and toll barriers, which were illuminated with sodium vapour lamps to provide safe conditions for traffic entering or leaving the expressway at night. Were spray painted on the road surface to define travelling lanes. This was the final construction activity on the project. In 1960, 1966, 3.5 years after its commencement, the first 10 miles of rural expressway in New South Wales was brought to completion. But this is not the end of the story. The fourth stage of construction is already proceeding on the southern side of the Hawkesbury River Valley towards Sydney. In the meantime, motorists using this road are now able to enjoy the comfort and convenience of fast travel under safe driving conditions. The Department of Main Roads takes pride in the achievement of surmounting the great difficulties associated with the construction of an expressway of world standard through such rugged terrain, and plans to construct other similar expressways throughout New South Wales for the benefit of the travelling public and, indeed, the whole community.